Hi guys, welcome back. Today we're going to be doing further pure mathematics 1 of the CIE syllabus code 9231. So in this chapter we're going to be doing roots of polynomial equations, and this is by far the simplest chapter in all of further pure math, and I'm going to make this video just so that we can break down everything there is to it and solve every type of question. So in this video I will be sharing my notes, and I will discuss two questions with you to truly affirm your understanding in roots of polynomials. So let's first start off with the syllabus and understand what we have to learn. So we gotta have to recall and use relations between the roots and coefficients of polynomial equations. It says to evaluate symmetric functions of the roots, or to solve problems involving unknown coefficients restricted to degree 2, 3 or 4, meaning it can only be asking of quadratics, cubics and quartics. The next topic says that you should use a substitution to obtain an equation whose roots are related in a simple way to those of an original equation. Substitutions will not be given for the easiest cases, and an example is where the new roots are reciprocals or squares or simple linear function of the old roots. This may all sound a bit tedious, but it's really simple. And so let's get on right to the notes. So this right here is the notes I've made for roots of polynomials. Some of you may know that this format is largely contributed to Notion. Yes, I use Notion to make this note, unlike my other notes on further statistics. So using Notion, I've been able to create a 3-page document basically detailing anything and everything in roots of polynomials, excluding the substitutions point. So let's begin. So roots of polynomials, let's start off. So there are basically 3 types of equations: quadratic, cubic and quartic. So this is how a quartic equation looks like. A quartic equation would mean the highest degree is to the power of 4. A cubic would mean the degree is 3, and a quadratic means that the highest degree is 2. So quadratic will be limited to this, cubic will be limited to this right here, and a quartic will be limited to this entire equation. So this is the basics that you need to know about what the questions are going to ask about. Now the next part is to understand the basic relationships using coefficients as stated in the syllabus. So what do I have right here? So what is a root of a polynomial? It means that when you have an equation, it equates to 0, meaning that when you plug in a certain value of x into your equation, it's going to yield a y value of 0 if you draw it in the xy plane. So that's what they mean by roots of polynomials. And so for a quadratic equation, you're going to have 2 roots. For a cubic, you're going to have 3 roots, and a quartic, you're going to have 4 roots. So that's just the basics of what we have to understand. So if we're going to have a quartic equation, we're going to be having 4 roots. And as symbolized over here, each of our roots will be taking a value of alpha, beta, gamma and delta. For cubics, we're going to limit it to alpha, beta, gamma, and for quadratics, we just use alpha and beta. So these are some of the relationships that you need to know. The sum of all the roots in any quadratic, cubic or quartic is negative b by a. What is negative b by a, as you may ask? So going back to this equation, it states that b, which is just adjacent to the highest degree, divided by a, and we're going to take the negative value of the division. So memorizing these would be a big help for you, because it is extremely easy to go across questions when you know this. There is a method of proving it, but I'm not going to go through this video because it is not necessary to learn how to prove that these equations work out. So do understand that these relationships are crucial. Now I'm going to tell you each of these by verbal. So sum a, it means that it's actually alpha, and that means that we're going to sum up all our roots. So alpha plus beta plus gamma plus delta equals to negative b by a, which is basically negative of the coefficient of the second highest degree divided by the coefficient of the highest degree. This is applicable to quadratics, cubics and quartics. The next thing is summation alpha beta. This means we are basically summing alpha beta. We're going to take pairs and product them. So what basically that means is that we're going to take 2 roots and then product, and then we're going to add them up for all. So for example, it may sound a little bit confusing right now, but let's take 4 roots: alpha, beta, gamma, delta. So sum alpha beta, meaning that alpha times beta plus the next root alpha times gamma plus alpha times delta plus beta times delta plus beta times delta plus beta times gamma and plus gamma times delta equals C by A. So if this seems a bit confusing, let's clear this out. So let's say that we have 4 roots to a quadratic equation. Let's say that these roots are alpha, beta, gamma and delta, right? So now what this symbol right here means is we're going to do the sum of pairwise products. What that means is that we're going to take one root, multiply it with the other, and that's one pairwise. Next we're going to take that same root and multiply with another, then we get another root. So let's, for example, alpha beta gives us alpha beta, alpha times gamma gives us alpha gamma, alpha times delta gives us alpha delta. Like this we're going to go on. Now we've used up all combinations we can possibly include with alpha. Now for beta we can multiply it with beta with gamma, which gives us beta gamma right here, and for beta we can also multiply with delta, meaning you get beta delta right here. So that's all the possible combinations you can have with alpha and beta. And for the very last one we can state is gamma and delta. So multiplying these two together gives us gamma delta. So what this means is that no matter what you say, there is always a combination of two roots that provides this. So alpha beta, beta gamma, all pairwise products must be included for this to be valid. It is extremely important. The next thing, and what this means is C by A. It means that we're taking the second highest coefficient and dividing by A. We don't need to use the negative sign here, but going next we would. So what is sum alpha beta gamma? It means to multiply 3 roots together and then add it with multiplying another 3 roots and another 3 roots. So in this case we're doing alpha beta gamma delta, and alpha gamma delta. So that's all the possible combinations you can have with the 4 roots and combining them in products of 3, and you get negative d by a. As you can see, negative d by a is when your linear coefficient is divided by the coefficient of the highest degree, and we're going to take the negative value of that, not the negative value. We're going to multiply with negative 1, which is symbolized over here. And the very last one is sum alpha beta gamma delta. This is your constant e right here, and it's not supposed to mean the exponential value, but it's just a constant e, a positive or negative constant, and alpha beta gamma delta, meaning that we're just multiplying each of these roots and we're going to get e divided by the coefficient of the highest degree, which is a. So these relationships, if we learn these relationships right here, it provides to be a really good base and to understand roots of polynomials. Understanding these would lay a solid foundation. So let's move on to the next part, calculate Sn. So this may sound a bit tricky, but it's in fact one of the easiest things. First of all, to understand what Sn is, it is commonly represented as Sn equals alpha to power n plus beta to power n plus gamma and so on. What this means is we're going to raise our roots to the power of n. So when n equals 1, we're going to have alpha plus beta plus gamma plus delta plus delta. When we have n equals 2, we're going to have S2, and S2 equals to alpha squared plus beta squared plus gamma squared plus delta squared. This goes on until n equals infinity or whatever it is. It really doesn't matter. We're just going to limit ourselves to small equations now. So as you can see over here, when s equals 1, we're going to have alpha plus beta plus gamma plus delta. So that if when n equals 1, we're going to have S1. That's alpha plus beta plus gamma plus delta. What you also know is that alpha plus beta plus gamma equals negative b by a. So learning this would mean that negative b by a is equal to S1. It's not really important to know this S1 convention to solve negative b by a, but it's a valuable advice. So yeah, these are just kind of things that you need to know. Now S2, what is S2? S2, if I'm going to draw S2 right here, it's going to be alpha squared plus beta squared plus gamma squared plus delta squared, and that's going to be our S2. So Questions often ask us to find alpha squared plus beta squared plus gamma squared plus delta squared. To solve this, we're going to do this formula right here. So when you plug in n equals 1 into this entire equation, we're going to get s2 equals s1 the whole square minus 2 times sum alpha to the power nb. So it may sound a bit tedious as of now, but when you plug in n equals 1, you're going to get s2 is equal to s1 the whole square minus 2 summation alpha beta. So that's what you're going to get if you plug in n equals 1. It may sound a bit tedious and all right now, but when I come to discussing the questions, I'm sure most of your doubts will be cleared, if not all. So when you have n equals 3, we're going to have we can't really solve this when you need to find s3, because you can't have n to the equals to 3 by 2. N can only take integer values. So for s3, you can use this formula right here, as you can see. This may be a bit difficult to understand at first. It would be good for you to memorize this, but once again, it's a little bit complex to use and it's a high chance of error. But if you have memorized it, it's really good. But what I like to do is using the summation method instead. So let's use an example over here. 2x to the power 4 plus 3x to the power 3 minus 3x squared plus 10x minus 29. So the above roots have alpha, beta, gamma, delta. As the above equation has roots alpha, beta, gamma, delta. This is something that we just need to assume. Okay, so that means that when you plug in x equals to alpha, a little bit wobbly there, alpha will be equal to 0, meaning that when x so that means that when you plug in x equals 0, x equals alpha, you're going to get 0, meaning that when you plug in x equals alpha, you're going to get 0 over here. When you plug in beta, what it means to be a root of an equation means that when you plug in a particular value of x, you're going to get an equation yielding 0, meaning that when you plug in x equals beta, you're going to get 0 as well, and this means you'll get 0 here as well, and so will you get for delta. So this is something that you need to clear out, and I'll explain it again. So when you so what it means to be a root of an equation means that when you a root of an equation is a particular value of x such that when you substitute that value of x into your original equation, you're going to get 0. And for a quartic, you're going to get 4 roots. For a cubic, you're going to get 3. For quadratics, you're going to get 2. Linears have 1, and constants don't really matter. So yeah, since all these equations are roots, it means that you can substitute these values of x and they will sum to 0. Okay, so it's really important. And we can also now add up the equations. So let's say that we add it all up, like a process of elimination, but not really. So if we were to add up all these things, we can factorize out the alpha to the power 4, alpha cube, alpha squared, and everything, and we're going to get something like this right here. So when you add all these equations up, remember, you're basically doing 0 plus 0 plus 0 plus 0. So you're still going to get 0. So let's just factorize this. If we add this up, we're going to get this. If you can see this over here. And what do you know over here? This does conform to our standards over here, where you have alpha to the power n plus beta n plus gamma n plus delta n. When n equals 4, you're going to get this right here, meaning that this is basically S4. When n equals 3, you're going to get this right here, which is meaning that this is S3. This right here is when n equals 2 in our Sn formula. And this right here is when n equals 1 into our formula over here, which gives us S1. And and this right here, I've made an error. Actually, this is going to be multiplied with s to the power 0, S0 right here, and I'll come to it just in a second. So this is what you're going to get if you just write it down. So if you just write it down in terms of s, you're going to get this equation right here. So when you add the two equations, you're actually going to get negative 29 times 4, and S0, if you see S0, it's just basically alpha to the power 0 plus beta to the power 0 plus gamma to the power 0 plus delta to power 0. That's equals to 1 plus 1 plus 1 plus 1, which is 4. And so you're going to get 4 times negative 29. It may sound complex, and we'll just go for this. So when n equals 0 for 29, SO will be equal to 4 as suggested earlier, and you can find S1, S2, S3 using these methods over here as I've shown over here. So once you find these methods, very easy to use, you can easily calculate S4, and you can use these equations over here just by plugging in S3, S2, S1 and so on. So let's say that we have to find S minus 1. What does that mean? That means that when n equals minus 1, so alpha to power minus 1 plus beta power minus 1. So let's just visualize that for you. Negative 1 equals to 1 by alpha plus 1 by beta plus 1 by gamma plus 1 by delta. Okay, so let's just simplify this. So if we were to multiply the denominators in such a way that we get alpha, beta, gamma, delta as the denominator, we're going to get beta, gamma, delta plus alpha, beta, gamma, alpha, gamma, delta plus alpha, beta, delta plus alpha, beta, gamma. It's not looking alpha, it's more of an A, and we're going to whole divide this by alpha, beta, gamma, delta. Gamma, delta. Okay, so this right here is what we're going to get if you just simplify this. And if you look closely or even understand the relationships that are shown, this right here, the numerator, is the same as this right here, sum alpha, beta, gamma, and our denominator is alpha, beta, gamma, delta, which is the same as this right here. So as you know that the numerator is negative d by a and the denominator is e by a, we are basically going to be doing this right here. Okay, this can be written as d by a. I think it is negative d by a if I'm not wrong, negative d by a, and then we're going to divide it with alpha, beta, gamma, delta, which is e by a. When you divide this, you're going to get negative d by e, and that's how you get the equation right here. I've just derived it for you how you work it out, but you don't need to prove any of this. Instead, you can write this down, which will give you a mark. So I do suggest you do this, but in case you want to verify, you can use this equation right here and plug in the values. So in this case, it would be, if you were to find s minus 1 for this one, we're going to get 10 divided by negative 29, and then we're going to put negative over it. So we're going to get negative by d. D is the coefficient of our linear term, which is 10. E is our constant, which is negative 29. So our s minus 1 in this case would be 10 by 29. Really simple work. And that right here is basically everything that you need to know for the first topic, and that's by using relationships of the coefficients. The next topic is to use a substitution to obtain an equation whose roots are related in a simple way. This topic is extremely simple. All you have to do is basically understand the question, and I'll show you exactly what I'm talking about in the questions as shown. Over here are a few questions that I've selected and solved. I'm just going to run through each of these so that we can find our weaknesses and evaluate them. So for our cubic equation right here, this is our cubic equation, and we can verify it by seeing the highest degree of the polynomial is 3. B, C, D are constants, and our coefficients of x squared, xn is a constant of course, and it has roots alpha, beta, gamma. It is given that the product of the roots is negative 1. So what does that imply? So first of all, they said state the value of d. How do you state the value of d? It's really simple. We found out that our constant is just the product of all the roots, meaning d equals to -1. Is that so? Incorrect. If we go back to our notes right here, you're going to see see, we're going to get negative d over a, meaning that our constant, meaning that we're going to get negative d over a. So whatever value we get over here, we're going to have to put a negative to it, meaning that we're going to get negative of -1, which is 1. It may sound complex, but with further work I'm sure you'll be able to understand this. But moving on, these are just the easier parts. The difficult parts I really get into the B and C parts of this question. So now we're gonna have to find a cubic equation with the coefficients B and C. So normally you can use a substitution of y equals x plus 1 and then x equals y minus 1. But instead you can also use the relationships. How do we do this? It's really simple. So to find the coefficient of our new cubic equation, we know that the sum of all roots gives us the coefficient of y squared. Our roots are now alpha, beta, alpha plus 1, beta plus 1, gamma plus 1. So summing them all up would give this right here. If you just look into it, you can see that we get alpha plus beta plus gamma plus 3, and that's S1. We've calculated our S1, and our S1 is basically negative b over a, which is negative b over 1, which is negative b. So when you plug in S1 equals negative b, we're going to get negative of 3 minus b, which is b minus 3. Similarly, the coefficient of y is the sum of pairwise products. So alpha plus 1 times beta plus 1 plus beta plus 1 plus gamma plus 1 plus alpha plus 1 times gamma plus 1. And this gives us this equation right here. When we simplify it, we're going to get this, solve for each, and we'll get a particular coefficient. Moving on, for constants, we can use the products, and as you can see over here, alpha beta gamma equals -1, which is a constant over here. Similarly, our new roots, alpha plus 1, beta plus 1, gamma plus 1, we multiply them all together, we're going to get this right here. And you can further evaluate this to get alpha beta gamma plus summation of alpha beta, which is just sum of pairwise products, plus S1 plus 1. We know that alpha beta gamma is -1, so -1 plus 1, 0. Sum alpha beta is c by a, which is c, and S1 equals to -b. So we're going to get negative of c minus b, which is b minus c. So that's your constant right here. We found a coefficient of y and we found a coefficient of y squared. Therefore, our equation becomes this. Bit of a cough here. Now, given that also that gamma plus 1 equals negative alpha plus 1, deduce that, well, this equals this. Okay, this is rather very easy. So you know that gamma plus 1, which is a root of the equation, is equal to negative alpha minus 1. So when you sum up all the roots, you're going to get alpha plus 1, beta plus 1 minus alpha minus 1, which is equal to beta plus 1. And that is negative b minus 3, which is negative b over a being 1. So I'm going to plug that in. I'm going to get 1 over here. Yeah. We're going to get negative b over a, which is negative b minus 3. I'm not going to evaluate this into 3 minus b yet. I'll tell you exactly why. Moving on, sum of pairwise products. As you can see, alpha plus 1 times beta plus 1 plus beta plus 1 times negative alpha minus 1. If you multiply this and add them up, you're going to get 0. So, and when you're going to add this up, you're going to get this right here. And that's equal to c minus 2b plus c plus 3. Alpha plus 1 times beta plus 1. So this is basically our sum of pairwise, and that's basically this right here. And the product of all our roots give us the negative of the constant. So that being said, we get this right here on further evaluation. Now we've evaluated this to become c minus 2b plus 3, and we've evaluated beta plus 1 as negative of b minus 3. So we get this right here. That's equal to the negative of our constant. We cancel the negatives on the left and right side. We get our equation as stated. Moving on, we need to find the values of S1 and S2. So S1 equals to alpha plus beta plus gamma. We know this, and this is really simple. That's equal to negative b by a. We found b to be the negative 4, so negative of negative 4 by 2 equals 2. S2 equals to S1 the whole square minus 2 sum alpha beta, and this is basically alpha plus beta plus gamma the whole square minus 2 summation of alpha plus beta plus gamma plus alpha. This right here gives us, okay, so we need to evaluate this relationship. Sum alpha beta, what is that? Sum alpha beta is going to be our second most highest degree in the polynomial. So our first highest is x cubed, second highest in this, so the equation right here is a cubic equation. So for a cubic equation, the highest is cubic, the second highest is going to be squared, which is the quadratic, and now we need to look at the third most highest, which is x. Since we have no coefficient for x, it means that the coefficient of x is equal to 0, meaning that we get 2 square minus 2 times 0, which is equal to 4. It is really simple to identify this, and when we move on to these equations, it's going to get a bit more trickier. So this is just a part of a past paper, and the same is for this as well. So over here we need to express Sn plus 3 in terms of Sn plus 2 and Sn. This may be a little bit difficult if we don't understand the conventions of summations and S terms. So how I'd approach this is by first plugging in n equals 0. There you have express S3 in terms of S2 and S0. So using the equations in our roots of polynomials equations over here, we can, using this equation right here, as we know how to add up all the roots together, we're going to get something like that idea. So when you plug in, we're going to get 2s3 minus 4s2 plus 3s0, and this is equal to 0. It's using the same idea as we've evaluated before, and since we're going to find s3, we are going to plug it in and rearrange it in such a way that we get s3. So 2s3 equals to 4s2 minus s3s0, and we can divide this by 2 to get this right here. Now we can plug in back our n plus 3 to get Sn plus 3 equals 2 Sn plus 2 minus s by 3 by 2 Sn. That's how we draw relationships between polynomials. Moving on, we have the third question, to find the value of s4. So using this equation right here and plugging in n equals 1, we're going to be seeing s4 in terms of s3 and s1. So this is what we get right here when you plug in n equals 1. And here raises the question, what is the value of s3? That's simple. When you plug in n equals 0, you're going to get this right here. So what we do is just plug in this value back into this equation to get this s4. And we found the value of s2 to become 4 and s1 as 2. And s0 is just alpha to power 0 plus beta to power 0 plus gamma to 0. And you know, anything to the power of 0 equals 1. So 1 plus 1 plus 1 equals to 3. And plugging in all these values, we're going to get 8 minus 9 by 2, which is 4.5. And you're going to get 7 by 2. 7 by 2 multiplied by 2 is 7. 7 minus 3 by 2 times 2 equals to 7 minus 3, which is equal to 4. That's how you find S4. There are more questions to this part, but that is the same as using substitution as we've covered over here. I hope the concept is clear to you and you can truly understand now what roots of polynomials is. So in this video we've been able to cover out this right here. Substitutions now, we can use the y equals x plus 1, but this video was created just so that we can get the grasp of roots of polynomial equations and just by using relationships. Substitutions is extremely easy to do and extremely easy to self-learn. That is not what I've come to make this video for. It is to help you guys understand difficult concepts. So substitution really easy to use, and it's just basically putting in a variable like y and then substituting it as y equals x minus 1 and so on. So x equals y plus 1. It's a really easy way. Once you read through it, it'll be extremely simple. You're gonna likely use substitutions, but it's important to learn the relationships as well. So as they said as before, it's not given for the easiest cases, and your substitution sometimes you may not be able to guarantee that it's correct. So how you would guarantee if you have any extra time on the paper is by plugging in your relationships and solving it together. So that's how we do all the questions based off roots of polynomials. I hope you enjoyed the video and actually understood and can take away some information regarding this. If you have any doubts, be sure to share it down in the comments, and please remember to like, share and subscribe and support the channel. Goodbye for now.